Explanations to each question on the ionic bond and covalent bond exam. Question number 1. The electron dot diagram or Lewis structure of a chlorine atom includes how many dots? Well, we know electron dot diagrams are models used to show how many valence electrons atoms have, and we use the periodic table to determine the number of valence electrons. The group that it is in on the periodic table reminds us how to determine how many valence electrons that atom will have. It is those numbers by the letter A that we determine those valence electrons by. So we find chlorine over here, it's element number 17, and we can see that it is in group 7A, so we know it has 7 valence electrons. Since chlorine has 7 valence electrons, we know it has 7 dots in its Lewis structure. The second question, which element would have the same electron dot structure as oxygen? As before, we determined how many dots it would have by the column it's in, and we can see oxygen is in column 6A, so we know it has 6 valence electrons. So any element that is in the same column as oxygen should have the same structure. So we know electron dot diagrams indicate the number of valence electrons atoms have, and all elements in the same group have the same number of valence electrons. Therefore, any element in the same group is going to have the same electron dot diagram. So in our case, the atom that has the same in our choices was sulfur. Question 3. Which is the correct electron dot structure for a silicon atom? So we just need to find the column that silicon is in to determine its number of valence electrons. And really we're looking at that it's in 4A. So we know it has 4 valence electrons, therefore it's going to have 4 dots around it, 1 on each side. Question 4 is simply asking what cations are. Here's some tricks to try to help you remember. The letter T in the cation looks like the positive plus sign, so cations are positive. And we can play that word pa, like in a cat. And the idea of always be positive to your cat. So cations are positive ions because they've lost negatively charged electrons. So naturally, the next question should ask what anions are. So an anion is a negative ion, and it's because they have gained more negatively charged electrons. Staying with this theme of ions, we're asking what type of ion do we usually find on the right side of the periodic table. So we can see here that the right side of the periodic table, they usually gain electrons. So if they're gaining electrons, they're going to have extra negative charges in their atoms, so these ions will be negative ions. So in question 7, we're asking what does the other side, the left side of the periodic table, produce? And on the left side of the periodic table, we see these are mostly metals, and these metals will lose electrons, so their ions are going to be positive ions. Question number 8. When an electron is added to or removed from an atom, what does the atom become? Well, see, we have a neutrally charged atom of sodium, 11 protons, 11 neutrons. There's no charge, but it's going to lose that 1 valence electron to become stable. So as it loses it, it still has 11 protons, but now it has 10 electrons. So there's 1 more proton than electron, so it has a positive charge. So being a charged atom means it is an ion. Question 9. What number on the periodic table determines the number of electrons gained or lost? Again, we're looking at the group number because they tell us the number of valence electrons, and if they have less than 4 valence electrons, they will lose those. If they have more than 4 valence electrons, they will gain more to get to that octet rule of 8. Question 10. Why do ionic bonds form? So let's use the classic example of sodium chloride to answer this question. Here we have sodium ions with a +1 charge, and chlorine ions have a -1 charge. Because their charges are equal, they both are 1, but they're opposite, sodium with positive, chlorine negative, they will bond together. 11. How many oxide ions are needed to cancel the 2+ charge of calcium in calcium oxide? So we have to find oxygen on the periodic table, and we can see it's in column 6A. That tells us it has 6 valence electrons. more than 4, so it's going to gain 2 electrons to fulfill the octet rule. By gaining 2 electrons, it's going to have a -2 charge. Because the charge of oxygen is equal and opposite to that of calcium, we need one of each atom to cancel each other out. 12. Identify if nitrogen will gain or lose electrons and how many to complete the octet rule. So here we see nitrogen is in column 5A, so that tells us it has 5 valence electrons, and because it has 5 valence electrons, it is 1 more than 4, so it's going to have 5 dots around its symbol there, showing us that it needs to gain 3 electrons to fulfill that octet rule. Much easier than trying to lose 5. 13. Identify how many atoms of potassium and how many atoms of sulfur will be needed to form the ionic compound potassium sulfide. So here we see sulfur has 6 valence electrons. Potassium has 1 that it could use, so one of those potassium ions will bond with one of the sulfur electrons. So we need a second potassium atom to be able to complete that. So what we will have is 2 potassiums and 1 sulfur. 14. Identify the charge magnesium ions will have. So magnesium has 2 valence electrons. It's going to be easier to lose those 2 valence electrons than to gain 6 electrons. So since it loses 2 valence electrons, it's going to have 2 more protons, giving it a +2 charge. Question number 15. Ionic bonding is the attraction between what? Well, as we've been seeing, it's the attraction between atoms that have become charged by gaining or losing electrons, and they have to be equal and opposite in their charge, so it's simply oppositely charged ions bonding together. Question 16. When positive ions bond with negative ions, what is the resulting charge? Well, again, they're equal and opposite, so in sodium chloride, we saw sodium has a +1 charge, chlorine has a -1 charge, so they're going to have to be equal and opposite. So since they have the same charge but opposite, the same value, the charges are going to cancel each other out. So since they cancel each other out, the total charge on that ionic compound is going to be 0. 17. Elements in column 2A tend to do what? Well, elements in column 2A have 2 valence electrons. Since they have 2 valence electrons, they're going to probably lose those electrons because it'll take less energy to lose 2 electrons than try to gain 6. So since they lose 2 electrons, they have a +2 charged ion. You can see that oxidation number down there. So they're going to lose 2 electrons and become +2 ions. Question number 18. What do the elements in column 7A tend to do? So that same concept, now we're in 7A on the periodic table, so that tells us these elements have 7 valence electrons. So since they have 7 valence electrons, they need 1 more to fulfill that octet rule, so they're going to have a -1 oxidation number. So having a -1 oxidation number tells us that elements in column 7A are going to tend to gain 1 electron, and by gaining that 1 electron, it's going to have a -1 charge. So we're going to use the classic covalent molecule of water to answer question number 19. We can see those 8 dots around oxygen, 6 of them red coming from the oxygen, the other 2, 1 each from the hydrogens. So we can see that hydrogen is going to share a pair of electrons with the oxygen. The other hydrogen is going to share the other pair of electrons with that oxygen. So covalent bonds result from the sharing of electrons, and it's an equal number of electrons by 2 different atoms. Question number 20 asks us to figure out the electron dot diagram of a lithium atom. So we find lithium, it's in column 1A. Column 1A tells us it has 1 valence electron, so the dot structure for lithium is going to be the symbol with 1 dot next to it. Our 21st question asks what type of covalent bond will Cl2 or chlorine gas form? And we can see chlorine has 7 valence electrons. It needs 1 more to become stable. So that middle pair there is going to be shared, and that would be known as a single covalent bond. Question number 22. What type of atoms bond in covalent bonds? So usually when we see all these different types of covalent bonds, we're finding atoms mostly on the right side of the periodic table, and these generally are nonmetals. So covalent bonds form between 2 nonmetal or more than 2 nonmetal atoms. Question 23, what type of atoms bond in ionic bonds? So here as we look at the periodic table, we see that atoms from the right side, those nonmetals, are going to be bonding with atoms on the left side, which are the metals. So in ionic bonds, we tend to get metals bonding with nonmetals. Alright, so we're on question 24, trying to figure out what the oxidation number for aluminum atoms are. So again, we find aluminum on the periodic table in column 3A. In 3A, they lose electrons. They're going to lose 3 electrons, so aluminum will have a +3 oxidation number. Question 25, how many valence electrons do sodium atoms have? So again, looking where it is on the periodic table, we can see sodium is in column 1A. By being in column 1A, it tells us it has 1 valence electron. In question 26, we're asked what happens to the valence electrons in a covalent bond. So going back to our covalent molecule of water, we can see that these bonds here are the result of electrons being shared. So here we have 2 shared electrons or pairs of electrons. So again, valence electrons are shared in covalent bonds. Question 27. What happens to the valence electrons in ionic bonds? So again, the textbook example is sodium chloride. Sodium has 1 valence electron, chlorine has 7. Sodium is going to lose that valence electron, transfer it over to chlorine. So sodium will become a +1 charge, chlorine will become a -1 charge. So we can get these equal and opposite charge happening because in the valence electrons are transferred for those ionic bonds. Question number 28. The melting point of covalent bonds. Covalent bonds, these simple ones are weaker bonds, so they're going to have low melting points. So ionic bonds, opposite. They're usually considered stronger, so their boiling point is going to be high. In question number 30, we want to know an example of a covalent bond. So again, we're looking at carbon dioxide, and we know covalent bonds are usually taking place between nonmetals, and they're going to share their electrons. So here we can see oxygen and carbon. These are nonmetals, and you can see in the diagram that there's 2 double bonds happening. There's 4 pairs of electrons being shared. So the example that was given, or the choice that we could choose, would be carbon dioxide. And our last question, question number 31, which is an example of an ionic bond. So again, going back to the standard sodium chloride, we can see here that we're between metals, nonmetals, and electrons are being transferred to form ions. So you can see that sodium is a metal, chlorine is a nonmetal, and in here you can see that electron from sodium is being transferred to the chlorine and ions are being formed, so the answer to our last question would be sodium chloride. I hope that this review has helped and you'll be ready to take the second version of this ionic and covalent bond exam. So good luck and Godspeed.